Hello friends, in this video I want to discuss about one of the most important topics in ML called bias variance trade-off. Trust me, if you attend any ML interview, there will be a definite question from this topic, so let's try to understand it. Let's say I have a population from which a sample is taken out, which is called as a dataset in ML world. Now I want to build a regression and a classification model for this dataset. I have three possible models fit here for the given dataset. The question is, which among these three is the best model? To understand this, we need to know types of errors in an ML model. ML model has three types of errors: bias error, variance error, and irreducible error. Both bias error and variance error are reducible, whereas irreducible error, as the name suggests, cannot be avoided. Bias error is introduced when we approximate a complex function with a simpler one. Model 1 suffers from large bias error. As you can see, data is complex, whereas the model that we have used, that is a red line, is the simpler one. Alternatively, variance error is introduced when we approximate data with a very complex function which fits not only data but also noise. Model 3 suffers from large variance error. As you can see here, our model overfits data. It fits even the noise also. Neither of them is actually good. Model 2 is the best model. It has low bias and low variance error. It fits data optimally. So best model should have low bias and low variance error. However, in practice, when we reduce bias, variance increases and vice versa. For this reason, we call it bias variance trade-off. The bias variance trade-off implies that a best model should balance underfitting and overfitting. It should be rich enough to express underlying structure in data and simple enough to avoid overfitting or fitting noise. As you can see in this graph, the model complexity increases, then the bias error reduces. At the same time as the model complexity increases, variance error increases. But at the optimal complexity, we also have minimum error or the optimum model. Below this point, we have model underfitting the data. Above this point, we have model overfitting the data. That's all about bias variance trade-off. But for a given dataset, how to build a best model with an optimal complexity is an important question to answer. That will be the topic of my next video. Until then, bye bye.